Hello everybody. In this concept session, we are going to discuss atoms, nuclei, one after another. Atoms contains these subtopics: alpha particle scattering experiment, so that conclusions of Rutherford about nuclear model, and atomic spectra, Bohr's model, de Broglie's explanation of Bohr's second postulate, their relation, whatever. So we'll see one by one slowly. According to Thomson's model, an atom consists of a positively charged core with electrons uniformly distributed over it, like seeds in the watermelon. Name of the something is typed here. Let me change it a little so that we'll continue. Name of the yeah, Rutherford model of Rutherford alpha ray scattering experiment. Rutherford alpha ray scattering experiment. Yes, that we are going to discuss. Rutherford alpha ray scattering experiment. In this is a failed model. Many reasons, but we need to develop our scientific attitude. That means how to think. Because today whatever we feel that it is correct, that may not be absolutely correct by tomorrow. So we have to develop our scientific attitude based on the experiments, observations. We decided this is the best one currently known, like that. This failed to explain stability of atoms. The number of alpha particles scattered at an angle is given by z square e power 4 by 8 pi epsilon naught square blah blah blah. It is such a big expression. Total number of alpha particles, actually Q should be here. Total number of alpha particles. Let me draw here, it's Q. QNT. Yeah, quantity of alpha particles that are scattered. And N number of atoms per unit volume. And R radius of distance of the screen from the foil. T is thickness of the foil. Atomic number of the foil. Theta is angle of scattering, and kinetic energy of alpha particle is E. Then N proportional to T, thickness of the foil, N proportional to Z square, atomic number square, N proportional to 1 by sine power 4 theta by 2, where theta is the scattering angle, and N is proportional to 1 by E square. So these are very, very important things based on alpha ray scattering experiment. Was conducted 100 years back without any latest equipments. See, so sharpen your brain, you too can think. Electrostatic force of repulsion between particle and nucleus, F is equal to 1 by 4 pi epsilon naught ZE into 2E by R square. What is this? Electrostatic force of repulsion between alpha particle, not particle. Here alpha is missing. Alpha particle and the nucleus. Nucleus of charge ZE, nucleus of charge ZE, and alpha particle charge 2E. Alpha particle charge 2E. So the force of repulsion between them is this one. Now, closest approach. When an alpha particle is projected towards the nucleus, then how close it can go to the nucleus? That is called closest approach. That is given by this expression. Where is that? Yeah. R naught is equal to, I will write here, I think it is not here, I will give distance of closest approach is given by distance of closest approach is equal to potential energy getting converted into kinetic energy of mv square. So that we are going to have R naught is equal to ZE square into 2, that means ZE square into 2 by 4 pi epsilon naught into kinetic energy. This is the distance of closest approach. With this you can do it. Here R naught is not subjected. I made the subject, that's it. And impact parameter. Impact parameter means how far the alpha particle is going from the line joining the nucleus and the velocity vector. See, suppose if it is the atom and it is the nucleus. Suppose alpha particle is going like this, are going like this, are going like this. So if it is the line joining direction, then this one is known as impact parameter B. Impact parameter is proportional to cot theta by 2, where theta is the scattering angle. More the impact parameter, theta will become less. Lesser the impact parameter, then theta will be more. That's why this formula is also important. Electrons orbit. Electrons orbit. Suppose in nth orbit the electron is revolving, then Fe is equal to 1 by 4 pi epsilon naught Ze square by r square, force on it, and mv square by r is centripetal or centrifugal force. Both are equal. So r is given by Ze square by 4 pi epsilon naught mv square. Kinetic energy of the electron is half Ze square by 4 pi epsilon naught r, or Ze square by 8 pi epsilon naught r, and potential energy equal to minus Ze square by 4 pi epsilon naught r. Total energy is Ze square by 8 pi epsilon naught r with a negative sign. So total energy, kinetic energy are oppositely signed. Kinetic energy never negative. Potential energy is double of it. Bohr's model of hydrogen like atom. Bohr's model. K Ze square by r square is equal to mv square by r, where k is 1 by 4 pi epsilon naught, and L is equal to I omega, that is equal to mvr nh by 2 pi, where n equal to 1, 2, 3, 4, and so on, where n is principal quantum number and L is angular momentum. Energy transition E2 minus E1 equal to h nu equal to hc by lambda. Radius of Bohr's orbit Rn is equal to epsilon naught h square n square by pi m e square by z. Now velocity of the electron in the orbit is Vn is equal to e square by 2h epsilon naught z by n. Angular velocity of electron in the orbit omega n is Vn by Rn. From that remaining things will come. Not a big task. But here I want to tell you, of course here it is there, but I want to tell you, I want to take that privilege. What is that? Energy proportional to 1 by n square, when n is principal quantum number. Obviously kinetic energy proportional to 1 by n square. Right? Next. Velocity proportional to 1 by n. R proportional to n square. And V by R is nothing but omega is proportional to V by R is nothing but 1 by n cube. And of course frequency is proportional to 1 by n cube. Time period is proportional to n cube. Many things you can solve with this formula. Right? Take care. Next. Energy of the electron in the orbit. Kinetic energy equal to 2 pi square k square e power 4 by h square mz square by n square. After simplification you will get 13.6 z square by n square for hydrogen like atom. If it is hydrogen atom only, then you will get 13.6 by n square only, no z square. Next, u is equal to 4 pi square k square e power 4 by z h square into mz square by 2n, just n square, and this will be 27.2 with a negative sign z square by n square. This is potential energy. Total energy will be negative of 13.6 only will be there. Next, the ratio of potential energy, kinetic energy, total energy is -2:1:1. Potential energy symbolized as U. For our communication sake we are using PE, but potential energy symbol is U. And yeah, U equal to -2k, E equal to -k, K equal to U by 2 with a negative sign. Energy levels of hydrogen atom. En2 minus En1 is equal to -13.6 of 1 by n1 square minus 1 by n2 square. Our wave number 1 by lambda equal to rz square of 1 by n1 square minus n2 square. Rydberg constant R is equal to me to the power of 4 by 8 epsilon naught square h cube c. For Lyman series falling into first orbit, and Balmer series falling into second orbit. Only Balmer is under visible spectrum, remaining are not. Passion, bracket, fund. So these are subsequent series. Next, in emission spectrum of total possible number of emissions lines from some excited state to another energy state n1 which is less than n2 is number of spectral lines possible n2 minus n1 into n2 minus n1 plus 1 by 2. These many number of possible things. and number of absorption lines possible from ground state to nth orbit are n minus 1. And if electron fall from nth orbit to the ground state, the number of spectral lines emitted by given is nb equal to n into n minus 1 by 2. This is the number of spectral lines emitted is given by if it is falling from nth orbit to the ground state. Okay, next. Bohr's model is applicable only to hydrogen and hydrogen-like atoms or single electron systems. De Broglie hypothesis that electrons have wavelength lambda equal to h by mv gave an explanation for Bohr's quantization of orbits by bringing into wave particle duality. So de Broglie wavelength is 2 pi r is equal to n lambda, where n is an integer, then only electron can be there. Now nuclei we are going to discuss. Nuclei lesson structure is atomic masses and composition of nucleus, size of the nucleus, mass energy relation, binding energy of course, nuclear force, radioactivity, nuclear energy. These things we are going to discuss. 1/12 of mass of carbon atom is known as one atomic mass unit. Its value is given by 1.66 into 10 to the power of minus 27 kg. Size of the nucleus is given by volume proportional to mass number. So V proportional to A, volume proportional to R cube. So R cube proportional to A, R proportional to A power 1 by 3. So this will give you size and mass number relation. Density of the nucleus is uniform irrespective of the mass number or atomic number. Its density of nucleus, density of all the nuclei is same. And ratio of velocities of two nuclei V1 by V2 is M2 by M1 is E2 by A1 is R2 by R1 whole cube. Kinetic energies ratio is M2 by M1 as P square by 2M and P is same. That's why whenever a nuclei is split into two. Then Einstein's mass energy equivalence is E equal to mc square. Mass defect of the nucleus is sum of masses of individual nucleons and the entire mass of the nucleus. Difference is known as mass defect. Packing fraction is mass defect per mass number, that is delta m by A. Per head how much it is losing, that is the concept of that. Next, binding energy is equal to delta m into c square. Delta m into c square. Here I want to write a small thing here. Binding energy can be calculated in two ways, depends upon the given data. If the mass delta m is in grams or kg, grams or kg, you have to take in kg only, and so that you can have binding energy is equal to delta m into c square, you have to multiply, so that answer will come in joule. If delta m is in AMU, then binding energy is equal to delta m into 931.5 MeV, million electron volt. So that you can multiply it with 1.6 into 10 to the power of minus 13, so that joule will come. Using this you can find out binding energy. Alpha decay of radiation. When an unstable nucleus decays alpha particle, then atomic number decreases by 2 units, mass number decreases by 4 units. So suppose P dissociates into D, then its mass number decreased by 4, atomic number decreased by 2. Beta decay, when an unstable nucleus sends beta out, that means beta minus particles are nothing but electrons. When an electron comes out, atomic number increases by 1, mass number remains unchanged. And positive beta decay, whenever comes out, then mass number remains unchanged, atomic number decreases by 1 in this case. Next, consider a nuclear reaction. X gives to Y and alpha particles and some beta particles, m alpha particles, n beta particles. Then A is equal to Q plus 4m and Z is equal to P plus 2m minus n. According to law of radioactivity, delta n by delta T is equal to minus lambda n, where lambda is decay constant. Here lambda. lambda is decay constant, and n is equal to number of nuclei present after time t is n naught e to the power of minus lambda t, and t equal to 1 by lambda log n by n naught. Activity R, the number of decays per unit time. R is equal to lambda n or lambda into n naught e to the power of minus lambda t. Rate is equal to r naught e to the power of minus lambda t. 1 becquerel is 1 decay per second. 1 Rutherford is 10 to the power of 6 decays per second. 1 Curie is 3.7 into 10 to the power of 10 decays per second. Half-life period T half is log 2 by 2 by lambda or 0.693 by lambda, and mean lifetime is 1 by lambda or 0.693 tau for half lifetime. And for parallel decays, lambda equal to lambda 1 plus lambda 2 or 1 by t equal to 1 by t1 plus 1 by t2. Nuclear fission, that means splitting up of nucleus into smaller equivalent fragments. Heavy nucleus splits into 2 fragments. Here it's a famous known reaction. Uranium-235 is a readily fissionable nucleus. On bombarding with neutron, it splits into barium and krypton, plus 3 neutrons will come along with, which are called secondary neutrons, and Q is the amount of energy liberated. In a nuclear reaction, masses of A plus B reactants, masses of C plus D products. If you go for the difference, then mass defect will come into C square, will give you energy liberated. So masses of products, masses of reactants difference into C square will give you this one. Power generated by the nuclear reactor P equal to Ne by T, where N by T is number of fission should occur per the given time, and E is energy released. X grams of substance is participated in a fission reaction, then power P is equal to Ne by T, and P equal to XNAE by AT. What is Na? Avogadro's number, and A is mass number, X is the amount of mass to be taken, T is for the given time, E is energy, P is power. Then everything will come with this. Next, nuclear fusion. The lighter nuclei combine to form a bigger nuclei to attain stability, then, and in this process also will get energy, which is in hydrogen fusion we are going to get 26.7 MeV of energy. Pair production means massless entities after certain mass or radiation of photon after certain mass, they form some what you call pair production. That means gamma radiation with 1.02 MeV of energy or more will give birth to a positron and an electron. 1.02 MeV is a condition for its minimum mass, minimum energy. The reason is electron's massless corresponding energy is 0.51, positron massless corresponding energy is 0.51. 0.51 plus 0.51 is 1.02. So gamma should be 1.02 MeV of energy to produce a pair. And if E is the energy of gamma photon, kinetic energy of each positron and electron is E minus 1.02 by 2. That is the energy acquired. But usually they won't share energy equally. Positron will eat more. In the siblings, you people will eat more like that. And pair annihilation, whenever positron collides with electron and they destroy themselves, and energy will be created there. That means mass converted into energy. So mass energy equivalence concept is here also, pair annihilation. The minimum energy of gamma photon formed in pair annihilation is 0.51 MeV. And push yourself to be great. And we'll discuss numericals in another session. Bye.